Very short notice, as you can see.
It's not too bad. It's not too bad. Oh,
It's funny now. The whole thing in German. That's the cool thing about Goodman. So you can just
Okay. Hello everyone and welcome to the second AWS Jersey meetup. When Rory approached me to get involved with the meetup group, I was a bit reluctant. And after some convincing and massaging, he slowly worked me into it. And when I explained to him like what we're doing on AWS, I think it got him. He convinced me a lot more. I got more excited. So also thank you to VAT IT for hosting us. We're very excited to be here, as well as expose to you guys some of the awesome stuff we're doing. I told my wife I'm not going to use the word awesome because apparently I use it way too much. So help me if I do. So just so you guys know, next month there's already another topic that's arranged, and it's going to be a deep dive into EC2. Explaining exactly what EC2 is, how to use it to your best ability, and that will be at DVD, right, Rory? So everyone's aware. And yeah, so on to tonight's topic, Kubernetes on AWS, and just so you guys are aware, I'll explain how we're going to focus this. I'll explain how we are using Kubernetes and really focus on how Kubernetes and AWS link. Because Kubernetes can run on anything. It can run on a Raspberry Pi, it can run on JMetal, it can run on Google Cloud, and I'll explain to you to get the best benefits of using it on AWS. Cool, so let's start here. So for those of you who don't know where we are, this is VAT IT, and what VAT IT does is basically we do VAT reclaim for companies. We're the world's biggest VAT reclaim business. If you're a company and you're doing business in another country, you can claim back that VAT. We do that for you on your behalf, and we take a certain percentage. So we're dealing with big companies here. We're dealing with HP, we're dealing with Duracell, Kellogg's, 8,000 more, and funny enough, one of our customers is Amazon. So that links into here, and this is where we can be found in all these locations, and all the technology is created here. In South Africa, this is our main processing center. All the rest of these offices are sales offices. So we are DHL's biggest customer. You might have seen some DHL boxes around the office. The guys put all the invoices in the DHL box, and DHL it to us in South Africa. We've got a huge processing center, basically the whole first floor of this building, and they sit highlighting invoices and putting it into our system. Right? That's the problem. That's why we are now automating, and now we're going to automate this whole process and re-engineer people's jobs positions to be able to enable them. Cool, so that's VAT IT. Working with these big customers also gives us a lot of problems, right? Not problems, but security risks. Big companies don't necessarily just hand over their data. You have to comply to a lot of their regulations. It is. We'll chat about that a bit later. Okay, so this is about me. My name is Josh Goodman, and I head up DevOps at VAT IT. I previously worked at Entellect as a software engineer. In my spare time, I volunteer as a paramedic for an organization called Hatsola, and I have a newborn baby with my wife. This is him. He looks like Boss Baby, I think. And I enjoy fidget spinners. So we've got some swagger, some fidget spinners, so ask some questions. So that's me in like my Zen moment, right? I'm in my paramedic uniform, fidget spinning. That's my vibe. And you can contact me at this email if you want to. Great. So this is the problem. This is what led us to our current setup. Right, we had a problem. Our problem was we needed to start integrating into different providers and getting their data. We realized that this invoice story is going to wear itself out soon, and we wanted to basically be wherever our customers are storing their potential VAT, whether it's using a third party such as Concur, which is one of the biggest expense management systems in the world, who also, by the way, use Kubernetes, whether it's SAP, expense, but I'm very sorry for putting up an SAP logo at a developer conference. I know that's very risky. Or SFTP. So this is DHL. This is what we want to move away from. We can integrate to do their VAT, but we don't want to be using them anymore. We want to be basically automating this whole process and pulling all these invoices using certain things. Right? The data can be variable in size, meaning a customer could give us gigabytes, terabytes of data, or they could give us small kilobytes. And we don't know what we're going to expect. We basically just pull in the data. Data at rest needs to be at a certain geographical location. Sorry, should have planned this. A lot of our customers, especially the European customers, right, need their data to be stored in Europe. If they're a German customer, it needs to be stored in Germany, etc. This proves to be quite difficult, right, without a third party such as AWS. And this line is actually what really pushed us to use AWS. Some of you might notice as AWS grows bigger, most of their data centers are just being sprung up in Europe. And this is exactly the reason why. Because of the data laws such as our POPI, etc., that exists. So just nice information, you'll see Paris data center was just announced, it should be up soon. Ireland, that's probably for tax reasons. And the more they grow, I think 1 in 3 will probably be in Europe. And security, as I mentioned before, we ran out of server space. Yeah, we don't want to invest in old servers anymore. It's just, as you know, servers are resources these days. And we need to automate. Cool, so that's our problem, right? So our solution. Cool, okay, so we decided to do Kubernetes. Great, so this is our current landscape of our cluster. I'll just run through the things. We're using Docker. I don't know how many people are using Rocket or other container. Maybe, is anyone here actually running Kubernetes? But the whole of VAT IT and one guy from synthesis. I'm glad. Cool, so this is a learning experience. So we'll go through the basics of it. Cool, so we've got Docker. All of our containers are in Docker. We're sitting in about 30% of our infrastructure running on Kubernetes. The rest is the old school running the server way. TeamCity is our build server. Chorus is what all of our images are based off of. Amazon Web Services. etcd is basically the brain of Kubernetes. It's its database, and then your Kubernetes nodes and masters. And Terraform, right? So does anyone know what Terraform is? Cool. So Terraform is basically an infrastructure as code tool. If you are using AWS in production or in anything, I highly, highly recommend that you look at Terraform. It's much better than CloudFormation. I'll be biased. Why? Because it can integrate into as many providers as, because it's open source. It's currently integrated into all the big cloud providers, and they're building out a Kubernetes integration. Very basic at the moment, but we're hoping for it to get much bigger. Basically, what Terraform does, we can do a whole lecture of Terraform. I'm not even touching on it tonight. But Terraform will allow you to define the whole infrastructure. Our whole Kubernetes cluster is Terraform, so it's infrastructure as code. If Ireland region goes down, we just change the region name, hit Terraform apply, and it spins up in whatever region we tell it to. security group, every EC2, what runs on that EC2, what runs in that bucket is code committed to a Git repo, and as a team we work on that infrastructure. Awesome tool, Terraform. Check it out. I can't speak better about it. Okay, so this is our current Kubernetes landscape. We have about 90 deployments running on Kubernetes. Between 100 and 200 pods, 12 to 20 worker nodes. That's machines that are doing all the work. So at any given time, depending on the scale, depending on the time of the day, at minimum we have 12, max at the moment 20 that can scale to infinity if we ever need it. 5 etcd nodes. If you are running a Kubernetes production instance, don't go less than 5. etcd needs a quorum, so the minimum you want is 3. If you lose one, you're down. So 4, you're touching, you're being brave. And 2 master nodes, that's just for redundancy, 1 in each AZ. You can run this on one at the same time, 2 is just better for load balancing, and if one goes down. We scale at about 20% today. Through our whole infrastructure that's Dev UAT live, we do about 20 deployments a day and 3 deployments to live. That's nowhere close to where we need to be. I think everyone knows that like Amazon, I think, deploy once every minute. So we're not Amazon, but we want to be there, right? So we need to be deploying at least 15, 20 times a day to consider ourselves successful. Pokemon Go, the biggest known Kubernetes deployment, they have 2,000 worker nodes, 2,000 machines. And that's what really allowed them to scale their application to what they are today. They scale at about 50% a day. So think of those machines, right? But then Google Cloud, so I don't know if I'm allowed to talk about them tonight. And as I was doing my research, someone said, I'm pretty sure it runs on my phone and not on Kubernetes. Cool. So this is Kubernetes talk, and a lot of you aren't running Kubernetes, so let's just talk about a little bit of the basics before we go ahead. So everyone's on board. Basic Kubernetes. What is Kubernetes? It's a container orchestration tool, right? I hope everyone knows what a Docker container is. If you don't, it's going to be very boring talk. Cool. So we've got all these Docker containers. In our case, we've got maybe 1,000 containers. How do we orchestrate them? How do we get them talking to each other? How do we scale them? This is what Kubernetes does. It runs and manages container. As I said before, it can run on anything, and it's inspired by Google's project that they call Borg. Everyone knows the story. At Google, one of their servers is misbehaving. They walk up to the rack, that's the server that's misbehaving, they rip it out, and they throw it in the dustbin. We do exactly the same. Our server is not behaving, go on AWS, delete. That's it. Kubernetes takes care of the rest. It'll provision another server, it will, all the nodes or all the pods that were on that server, it will migrate, realize where they should go, how they should speak to each other. Funny enough, people think that Google owns Kubernetes. They don't. Kubernetes is completely open source. Less than 50% of the commits come from Google. So you've got majority of people just giving their time to Kubernetes that aren't at Google. And we want to manage applications, not machines, right? Done are the days when we go to the data center and look at the machine and SSH in and realize, oh, this thing's not working. We don't care about that anymore. We've gotten past that stage. We want to just write applications and the rest must take care of itself. And that's truly what Kubernetes enables, if you understand it and if you can implement it properly. So at the beginning, yes, you are going to be managing machines, but it's to achieve this purpose as to not manage it. And as the meme says, is it Kubernetes, K8? I don't know. I don't even know if it's COPS or KOPS. I'm guessing it's like one of those things because you never heard people like who talk about it. So great. On Kubernetes, there's some concepts we have to understand. So a pod is a basic unit. For all purposes, we can just talk about a pod as a Docker container for us. You can have multiple containers, Docker containers in a pod. If you want like your Nginx server next to your Node app, next to your small database, don't put a database in the container, but anyways, this is what a pod is. So let's think of a pod as a Docker container. This is your container, this is your application. Let's read here, actually, pod, blah, blah, blah. Pods can be scaled, meaning when we replicate this, that pod will be replicated exactly the same, right? So exactly the same Docker container we have is going to be replicated in exactly the same manner. Okay, a node. A node is basically a machine that we give to Kubernetes to use, right? We say to Kubernetes, here's your node, you use it how you want. We might set it as this type of node, maybe it's our extra large node, or it's our super fast node, or it's our GPU node, right? And we want Kubernetes to use it to its maximum ability. So you can see here it will provision pods on this node as it needs to. It's known as a minion, and these are the machines that you literally just rip out, or in, however you want. How's it, guys? So we start a little bit early, but take it slow. We just like defining Kubernetes stuff, and we haven't gotten to the crux of the top yet. Great, so that's what a node is. Pods run on a node. That's what you need to know, and think of a node as a machine. A service, services is how we interact with our pods, right? So the service is basically a load balancer to it. If we have 2 pods, let's think of this as our service. So here we've got 3 pods, and if our service is front end, it will loop through the 3 as we go. First call, second call, third call. Important to know that it does that, right? It doesn't remember where you came from, so you can't store state in these pods. You don't know which pod you're going to be speaking to, and in 5 minutes that pod might be dead. Because we're scaling, we're not scaling, etc. So very important to think how you're going to design your application to run on Kubernetes. Right? It's not the old school way in which where we can store sessions in our application. They need to be stored differently, either on the client side, on the database. And in AWS, we use a 2 load balancer approach, right? So we will have a service here. We can define a service as an AWS Elastic Load Balancer. So it's going to hit this load balancer, then speak to your Kubernetes service that will direct it to its pods. Guys, if anything is not clear, if you want to, if I'm talking utter rubbish or you want to complain, criticize, please just jump in. It's an open forum. Yeah, so important to know that distinction for AWS. What?
Sorry, when did they put in support for the ELB? Because I know a while back they didn't support the ELB as a service for Kubernetes.
So we jumped onto Kubernetes when they were on 1.4.7, I think, and we had it then, and that was about a year ago. So from my time of working with it, I've always had it. That was probably before that. Yeah?
Has Kubernetes rolled out support for the version 2 or the latest version of load balancing in AWS, so your application load balancing?
Yeah.
No.
Not yet. Yes. Okay, not there yet. I think as time goes on, we'll hopefully get all these things, but if you are interested in that, there's a special interest group that you can join, probably on load balancing. They have them on every single topic, and you can drive it forward. You develop it yourself and get it merged in. Cool. So that's a service and a cluster, right? So now we're putting it all together, and I'll speak a bit about, this is our cluster, so representation of it. And the cluster is how everything comes together. So as I mentioned before, we have etcd. etcd is our database where it stores everything. We have our master nodes, and we have our worker nodes. So this is how we've gone about it. Let me just step here. So our worker nodes are auto-scaling groups, AWS auto-scaling groups, and these scale as needed. I'll explain to you how we do the scaling just now. We have our live auto-scaling group nodes, and these are reserved, right? very important with Kubernetes, understand what you're deploying, right? Money gets spent very, very fast on AWS. If you see this machine that you like, and you're like, oh, the CX-XXL with 64 GPU is a machine that's going to run this thing, awesome. Just do a quick cost calculation and decide. So we've spent a lot of time understanding where our costs are going, and this is what we've come up with. So our whole live instance is all on reserved, right? Reserved means you're basically going to take out that machine for a year or 3 years. Go 3 years is a little bit cheaper. And you can choose to sell that back to AWS on their market. But our live infrastructure we don't want to lose, and our etcd masters and this auto scaling group on live. So in our deployments we assign these applications to run there. Now our Spot instances. Now Spot is basically a bidding place on AWS. AWS have all this excess server capacity, and basically you can tell them, I'll give you X amount of money for that machine, and you can take it away at any time. Sorry. As John said, there's also, like I alluded to, there's been a lot of development on Spots. You can get Spots for a lot longer. This is all Terraform, right, our Spot instances, and Terraform hasn't caught up to there yet. But basically, at any point in time, we can lose our VAT instance, but we don't care about that, right? We just up our bid, and hopefully we get it back. If we don't get it back, we up it more. John?
You're able to automate that through Terraform. So your Spot instances go down, you have to automate that.
We haven't automated that yet. We've lost our instances twice in a year. So the time of going to automate it hasn't proven itself yet. If it was live, we would do it.
Yeah, fair enough.
Yeah, but we've also, like, let's say we're paying at 60%, we're paying 50% of the reserve cost, we'll pay that extra 10% to kind of make sure that we have it. So we won't be on the bottom. There has been, there's a lot of private repos that you can check out that do that automation around it, and even help you run live instances by monitoring it. You can look on, I'll just show you quickly while we're at it. EC2. It's important to know this stuff if you guys are going to be getting the cluster. Go Spot instances. I can't see now. Spot requests. Use this pricing history calculator. Very cool little thing. So M4 extra large or large is basically your best value for money, and you can see the on-demand cost and what people are paying, right? So what people are paying 24 cents an hour for, you can get for 6 cents an hour now. A cool way, if you guys are going to be working for a machine for an hour, definitely use Spots. I mean, while I do that, you can spin up. This thing is really cool. Anyways, sorry, wasn't meant to dive into it. And then we have the VPN. We're using the VPN on the VPC, and that is only on this node level, right? If anyone ever gets into our infrastructure through our VPN, we don't want them to touch our masters. We don't want them to touch etcd. They must just be on the application level. And it allows our applications to speak to services that we have in our infrastructure, which is sitting at Terraform. Great. Okay, so that's basic Kubernetes. Any questions? Yes, Ari.
NCD, so that's database, right?
That's basically a key value store.
Okay.
And when you submit a deployment or a service, it will save it to etcd. The master will continually check it against etcd and check it against what's running in the cluster and provision it. The new COPS uses, or KOPS uses S3 bucket for its etcd storage. So it's a cool way to save yourself 5 machines.
And that's across Dev UAT Live, it's the same store, it's the same.
So we ourselves are only differentiating Dev UAT Live on a namespace level on Kubernetes. We don't have separate clusters. Maybe it's something we'll look at in the future. Cool. Okay, so this is now where Kubernetes parts AWS. As I said, I'm a paramedic, so this is actually what a real heart looks like. It's not that red, fluffy thing. Cool. Okay, so I know Amazon have their own version of Kubernetes or in the repository. So they can only access the repository that stores their application, where a normal Docker registry, you have to log into the whole registry. Very cool, as well as you give your Kubernetes cluster access to this repository, it will pull from there directly. You don't have to worry about it pulling from another Docker repo where you don't know where it's hosted, or you're hosting it yourself and you're worried about the persistence of those images, etc. So very cool thing, repositories, definitely use them, even if it's your own Docker repo that you need to host. Cool, and they're very cheap. We've got like, I think, more than 40,000 images and we pay like $6 a month. Very cheap. Okay, so Kubernetes service. I thought like everyone would look at this and be like, that looks weird, but because you guys haven't used Kubernetes before, it doesn't look weird. So a couple of things that are different. This is what a Kubernetes service definition looks like, and this is what you would commit to your Git repo, and it defines a service which is going to speak to your pods. And basically, this is our service, this is where it lives. We can differentiate on Kubernetes on the namespace level, so that's basically like a segregated section of Kubernetes that where stuff lives and they can't speak out of it unless you give it permission to. And where I wanted to focus here is how it integrates with AWS, right? So one of the things I'll pick up on is this load balancer source ranges, where you can allow your elastic load balancer only to speak to incoming IPs of this. So we're locking it down to our network here, and this is how we all our dev VAT stuff is only accessible by us. We can also do that on the VPN level, but we want to access it through the load balancer so we get that same experience that our clients are getting. Yeah, let me dive into this a little bit more. So Route 53. Route 53 is Amazon's DNS provider, and it allows you to upload your URLs to them, and you can control them. And we uploaded our whole company stuff there. We've got, I think, 83 URLs there. And the awesome, I said it again, the great thing of the Route 53 or Route 53, as they say on the tutorial videos, is this geolocation ability. So you have your URL hosted there, and you can control where your application gets routed to depending on where a person is accessing your application from. So a person accessing your application from Europe, you want to direct them to their closest data center. A person accessing your location from Nigeria, you want to send them to some other site. That was a joke. Sorry if anyone. I don't know of many services. I haven't done much research, but from my knowledge, AWS really have got the market share in that ability. And obviously with AWS, that's integrated into all the applications, so you can direct it directly to your load balancer, etc. Funny enough, Route 53 is one of the only AWS resources that is like global. Doesn't live in a specific data center. And all the rest, you kind of have to choose a data center like Ireland or Paris or whatever. This one is just like on a global level. So that presents its own challenges. Obviously, your DNS provider must update as fast as Route 53 is. So we recommend always using Google's DNS 8.8.8.8. Don't use your local one because it just doesn't update fast enough to their servers. And 90% of the time, when you can't reach your application, it's because your DNS hasn't propagated, as will probably happen in my demo just now. Cool. And this is kind of what the screen looks like for the DNS, for the Route 53 management. As you can see, you can provision your own domains here. They don't have .ca yet, but you can always import your domain to them, and you can do it will alert you when your stuff's about to expire, and the traffic management is where you're going to do your geolocation routing. Great. here's a fantastic little app that you can run on your cluster. It's called Route 53 Kubernetes, and this is how we define a deployment in Kubernetes. The deployment explains to it how to provision it. It's part in this cool Docker image, and what that does is that runs on your cluster. It looks for this label, Route 53, in your service file, as we had before, and it updates your Route 53 config to give it this URL. Providing you have that URL, that domain in your Route 53, right? And so this is allowing us to dynamically provision domains. So now our domains that live in our config, which is great. You have to give your worker role in Kubernetes access to these IAM roles. So as we can see, there's all the Route 53 stuff, and for some reason they want access to describe your load balances. I don't know why. They can have access to describe my load balances, I don't mind. As long as they're not like provisioning machines. So that's where it integrates very nicely into AWS. So you store all your domains on Route 53 and you can choose what domain you want. Cool. So SSL has many developers. So it's like a discussion, I'll call it discussion, that we have, like, who's in charge of SSL? Is it dev? Is it DevOps? Is it infrastructure? Is it this guy? I don't know. If anyone has an answer to that, please come talk to me. I'd love to hear your opinion.
Not there.
So here's the AWS Certificate Manager, a great little tool. When you run a cluster, a very nice idea is to buy yourself a wildcard cert of a domain that you want to use, and you can use that for all your SSL. And you upload your cert to the Certificate Manager, and then we can use this lovely thing, this little thing here, service.data. I know you're using a beta thing in Kubernetes, but I think it's stable enough to use. And it tells it what service to use, what cert to use. This is the ARN. Every resource in Amazon gets an ARN, an Amazon resource name, and it's basically along good with your account number that you can use. And this will give that SSL cert on your AWS Elastic Load Balancer. Right? So it's important to know that SSL termination is on a load balancer. So as soon as it hits Kubernetes, you don't have SSL. If you're comfortable with your security around that, kudos. Some stuff it doesn't play so nicely with, like Apache, as Todd and I will know, who spent last week trying to get SSL working in Apache, and Apache wants those SSL certs inside of it to like turn on SSL. So depending on your application, the newer applications, we're happy to terminate SSL at the load balancer. So then the guys who do provision your certs, it's literally just a re-import cert. You don't have to go provision those long cert chains and the intermediate cert and the leaf cert and SSL pocket. This helps us a lot. Great. Pods. Okay, so as we mentioned before, what a pod is, it's basically a Docker container. And I'm going to chat a little bit about how they interact with IAM. IAM is Amazon's identity access manager. And it's like I am this, like identity. And I thought it was funny. I don't know if they planned it that way. So this project with which Kubernetes core contributors have spent a lot of time investing in is called Kube to IAM, which basically gives your pod an IAM role. So if you're storing stuff on an S3 bucket, you can give them that role to allow only that pod access to that S3 bucket. If you need access to a RDS, a database, and basically anything that you can do in IAM, you can give your pod the ability to assume that role. Very, very cool project. I don't want to lie to you. We tried to run it, we couldn't really get it that stable, but we didn't invest the time in it. This is like the golden way to do it. What we're doing at the moment we're passing through we're creating IAM roles and we're passing through them as secrets. AWS Kubernetes secret is basically like an encrypted base64 user access key and secret key, and then it will assume that role using the AWS CLI in that pod. This is the gold standard of how to do it, and this is how you go about it. You run this deployment. This deployment, which is a daemon set. Daemon set basically means that this pod should run on every single machine that you have, and you give it these IAM roles. The assume role, that's the golden key word there, right? And effect allow all. So assume role. Every machine, every EC2 machine on AWS has the ability to be an IAM role, and this is what you're doing. You're saying, please allow me to assume that role. You're allowing the pod to assume the role of the machine. So that's how Kubernetes can integrate on a pod level to IAM. Any questions there? Okay, nodes. So nodes are machines that we use to host stuff on. Obviously, we want to get the max out of our nodes, right? If we have 4 gigabytes of memory, we want to use 3.99999 gigs of that memory before we provision a new one. And we don't want like that whole like excess wastage, right? That's what we're trying to avoid. That's why we set up this whole cluster. So auto scaling allows us to do that. We have a cluster auto scaling on AWS. So this is the official auto scaling that KOps or COPS uses, and this is how it runs. They're currently not in production yet. There are some funny things on it. So one of Kubernetes' main goals is to allow auto scaling. I personally don't think that they're there yet. There's still a lot of work to do to get there. But this is how you can do it on a small scale level as well. But then I'll explain why I say that now. Okay, so you run this deployment, and what this deployment is going to do is you're going to tell it what auto scaling group to watch. That's when you're going to define a minimum number and a maximum number of nodes. And you can give it some other flags. I think I put one here, scale down delay. So every time it decommissions a node, wait 5 minutes before it decommissions the next node. Don't put a scale up delay because then you're just going to cause issues for your users if you've like gone viral and you want to scale up really fast. Scale down, you can do that. Depends how much you scale. Skip knows the local storage, that's really nice. Local storage. Why? Because of the way Kubernetes interacts with storage is that it mounts it, demounts it. There can be a lot of issues around that. You might not get the same volume mounted back into your container. It takes long. Across availability zones, be very careful, right? Elastic, what's elastic? ESB. What does it stand for again? So many elastic block storage, EBS. Doesn't go across availability zones. So be careful around that. These are very, very, very important when you're doing auto scaling, right? So every deployment and every pod you can give it these limits and requests. So your limits is basically how much of the CPU and memory your pod has access to. And Kubernetes is going to block off that amount of memory for the CPU. So if we're running an M4 large and it's got 4 gigabytes of memory and we say we can get 100 M of that, we can run 40 of these containers on there. Hope my maths is right. Request is the bursting of that, meaning it's allowed 100 M, it can burst over 100 M, another 100 M. So if you want to get auto scaling right in your applications, understand these limits, right? Because then it will pack those nodes as tight as possible on those, pack those pods as tight as possible on those nodes, and it'll give it access to what it needs. The worst is when you have an application that's on a node, like a Java application, that is using a lot of memory, but it's just not able to get more memory, and it's going to be slow.
Rory, how do you feel about that?
I'm right here.
You mentioned last time in your talk, Java and
Good on the cloud.
and the JVM. It just doesn't play well in these environments, right? We saw it at the last talk in Lambda, just running the JVM uses, I think, half a gig of memory. So yeah, understand your application, dive deep into what resources it's going to use, profile that thing, and like make that thing like your baby, understand it, inside and out. So, okay, let me go into why I think this is bad, right? This scales at a linear rate. You can do auto-scaling on the auto-scaling group itself. It also scales at a linear rate, meaning I need a node, spend 5 minutes provisioning that node, spend another 5 minutes waiting for the kubelet to be live and introduce itself and deploy, right? So you're looking at golden scenario, it's 7 minutes before you get your new node. You're not going to be able to provision 100 and 200 nodes at a time. I don't know if any of us are running those applications that we do need to do that, right? But like, for example, Netflix, right? They need to do that. And something like this won't work for Netflix, and something like this won't work for something that's going viral and needs to do, like Pokemon Go. They couldn't use this. So I'm sure they've got their own kind of technology around that. I know Netflix, they've got like set times, like they know 6 o'clock's coming, at 3 o'clock they start the process of spooling up those machines to reach that capacity. So on small scale applications, when you need to scale, 8, 10 nodes, and you're happy to wait that time that it's going to take, this works perfectly for you. That works perfectly for us. We aren't at that place yet where we have to scale hundreds of machines at a time. It is a limitation, and just as long as we are aware of our limitations, we can work around it. We can have, in the Elastic group, we can have timed scaling, turn it off at night, turn it back on in the morning, etc. Think about how you want to use those things, right? All these things save us money if we're running. There's no point in stuff running that's not being used.
What's the difference between a node and a cluster?
So a cluster is how everything comes together, including etcd, including the masters, including the nodes. A node is a machine, but think of it as just a machine that we give Kubernetes to use how it wants. Cool. So, any questions on auto-scaling?
Maybe I missed it. Is this auto-scaling on an EC2 level? So I can know from an ECS point of view.
It's on the actual EC2 auto-scaling group.
So on your boxes.
Yes. So you can create an auto-scaling group on Amazon where you tell it exactly the node that you wanted to provision every single time, and that in our case is going to be a Kubernetes node, and that's this name that you're going to give it here. They call it K8 working auto-scaling group 1 and auto-scaling group 2. And yeah, so it's on that EC2 auto-scaling group level. Cool, so let's just recap on what we said. From our perspective, this is where AWS has met Kubernetes and the great things you can do around it. EC2 Container Service, use it as a registry. Route 53 as your DNS configuration. Certificate management, Kube to IAM, and auto-scaling. Some very, very cool AWS services that you can use to integrate into your cluster magically. Okay, so hiccups and limits, right? This is some of the problems we found with our cluster and our migration. This picture speaks immensely to us, right? Taking legacy software and trying to put it onto the cloud. And then you've got this little guy here that is deploying his little cloud native app or whatever. Yes.
What do we call our proprietary legacy software?
So our legacy software's name is Dragon. That's why this dragon is to us. All the stuff is named after dragons like Ghidorah and Khaleesi, and so we feel strongly about this image, and I really feel these guys. Anyways, some of the limits that we've hit: AWS rules per security group limit. So a lot of the things in AWS, right? How many people actually use AWS? Just want to see. So you've always hit one of their limits before, right? Either you've used too many EC2s, or you've done something, and it's usually a simple like email or phone call. It's like, yeah, please give me more load balances, please give me this, and they say, yeah, sure, why do you want more? And then they just up your limits. They don't do that for security group rules, the actual rules per security group. And the way they've architected AWS doesn't allow them to do it. So you can only have 50 rules in your security group, meaning that you can only have 50 load balancers speaking to your cluster. So, yeah, think about that. We came up with a workaround around that. Cool. Money, always going to be a limitation, especially on AWS. Understand what your stuff is using and how much it costs. The biggest gripe that a lot of cloud developers have is that there's no way to really control your bill, right? I know you can have budgets and stuff like this, but it doesn't really work. So when that bill comes at the end of the month and it's however many thousands of rands, and you have to justify why, yeah, it's hard. Docker in Docker. So we had a need to run a Docker in Docker instance. So that Docker, running in Docker, running on a VM, running on AWS is probably running on the EC2 themselves, I don't know. So yeah, it's Docception. It was very slow. It was just a limitation we had. I don't think we actually came up with a workaround. I know that you can use a Docker instance running on the underlying machine, but we didn't have that interactivity that we needed. Our upgrade path, right? So because we're running I'll call it custom version of Kubernetes, if you kind of stuck to the vanilla COPS, to Tectonic, to all these things, cube up, your upgrade path was pretty easy. It was like a command, like Kubernetes upgrade. Unfortunately, that's not the way we went, and our upgrade path is really hard, where we have to do one machine at a time and massage it, and it's gotten to the point where we're going to, as I'll chat later, we're going to migrate to a more supported solution. Because we're like DevOps, we don't want to be there like hacking at machines. So, anyways, Windows services running on Docker. Microsoft have really come to the party lately with Docker and containers. They released their Microsoft images that are quite cool and they run nicely, but you have to run them on Windows machine, most of them. .NET Core can run in Docker. It's not, as Rory mentioned before, it's not production ready yet. So this goes into how you're planning applications. About 40% of applications are written in C#. And you can actually have a Kubernetes node that's Microsoft based, but none of the big providers support it, so you can't have it in COPS yet. And I think you should think strong and hard before you do that. It's going to be the kind of thing, like, it's going to be a pet. Right? In AWS we speak of castle, not pets. So these machines that we spool up and spool down and delete, and we don't really care for them, where the old school pets that you gave a name and that you installed all your resources on nicely and made sure it was always up. So think about that, Windows. Docker daemon hanging, we had a problem with our Docker daemon, and I think it's just a limitation on Docker as they do more development on Docker and move to, I think it's called Moby, what they're trying to integrate into Docker. It'll become a lot more stable. So we have a cron job that runs on our nodes and just checks if the daemon is hanging. And if it is hanging, it just deletes that machine. RBAC policies. So Kubernetes has the ability to give RBAC policies, so role-based action controls, whatever, to users. Now, the limitation on that is very cool. You can say this developer only has access to this namespace, this developer only has access to this deployment, this pod, and they can do certain actions on it. But the dashboard of Kubernetes, the GUI, needs its own role. and you can't give them an RBAC policy. So if they get access to the dashboard, they've got access to everything, which I'll show you now. And persistence. Persistence is always going to be a hard thing in container land. How we store our stuff, how we store state, databases. You need to understand persistence, understand where your stuff's being stored, understand what volumes you mentioned before because of our upgrade path and our custom infrastructure. We're looking at chaos or COPS. We want to be on a more supported solution, so we're definitely looking at that. Kubernetes. So Kubernetes is our vision, right? And Kubernetes is also a project under Kubernetes, and this is where we're aiming to, and this is the ability to spin up these Kubernetes clusters in any region in the world, whether it's AWS, Google Cloud, DigitalOcean, and have them speaking to each other, have the data speaking to each other, and yeah, that's where we want to be. That's what we're building up to, is this massive cluster that spans infrastructure, spans countries, and hopefully leads us to like a local implementation of that. So AWS SA, I don't know, is anyone going to the AWS conference next month? Yeah, cool. So apparently there's going to be a big announcement, and we're all hoping that it's going to be a AWS local data center. Yeah, we can just hope, right? Azure just announced their data center in South Africa 2 weeks ago.
No, the Cape Town and Joburg.
Yeah, so AWS will also have 2 data centers, right? They've added these zones. I think minimum they have 2, generally they have 3, so it'll probably be Cape Town because that's where the EC2 team sits, and Joburg because makes sense. We don't know, we can only speculate. Into other cloud providers, I don't know if I'm allowed to talk about other cloud providers here, Rory. So obviously, like with the S3 downage, what's the downage? S3
4 hours.
4 hours when S3 went down the other day, we were affected by it, and of course Amazon stole their S3 dashboard on S3, so they couldn't even tell us that they were down. So having a redundancy just into another cloud provider would be great, and maybe they're in a region where we want to be. Separate their VAT cluster. Some of our clients are very pedantic on us running cloud environments in cloud. They don't really understand the infrastructure that we're providing, so we might be like kind of pushed towards that from a compliance point of view. Monitoring, I'm going to be doing a lot of work around that, understanding exactly what our Docker containers are doing, understanding the resources that they use, and that will feed into auto scaling. And this complete custom environment is this ability that we want to give our developers, the ability to kind of create their own environment. So if they want to test how the application interacts with certain containers, they would kind of have a GUI where they say, I want this container, this container, this container. And Kubernetes would just spin up that and give them that environment. So yeah, that's where we're heading. Yeah, this is like a kind of diagram of Kubernetes. So we have our Google Cloud, we have AWS, we have our private cloud, and we just have one control plane that speaks to all of it. Hopefully next year this time I'll demo that. Yeah, so let's do this. Okay, so what I thought is I'll keep this basic. So this is the Kubernetes dashboard that I spoke about that has the problem with the RBAC policies, and I can do this all on the command line, but it's just a nice interface to visualize actually what's going on. Okay, so let me go a bit through here. So this is the ECS repository, and I created a repo here called AWS demo. You can view how to push your Docker containers to the cluster here. Here's our Route 53 rules for, it's called VAT.io, which is our wildcard search domain that we're going to use. Our certificate manager, which is storing our star.valid.io search. You can see star.valid.io and our ARN, and this guy we don't need. And this is Team City. I've made a build here for AWS demo. You can see what my build is doing. There you go here. So this is what my build is going to do. It's going to log into AWS. It's going to build my code. It's going to tag it how it's meant to be tagged for the repository. It's going to push it, and it's going to speak to Kubernetes and tell it to update. And this is how every single one of our CI/CD kind of steps looks, right? So CI/CD is contained on the Docker level, and we only have like 3 things installed in our Team City agent, and that's Docker, AWS CLI, Kubernetes. Nothing else needed. We can, like the days of going and installing this version of Node, that version of this version of that, that must all be taken care of on a Docker level. Okay, so here's my project. So it's called AWS Demo, because that's what it is. Here's my Docker file, and it's basically installing an Nginx file, and here's my thing, and it's going to say hello world. So if we look at our thing, we can see we're in the AWS namespace, and there's currently nothing deployed and no services. So I'm going to be a good developer, and I'm going to test my code. AWS demo docs. I'm going to build my container locally, and as you can see, it's really fast. Docker run AWS, and let me run it as a daemon. AWS-demo. Cool. So go to localhost port 80, and plus it didn't work. Why not? See,
exposed port.
yeah, dash D. Thanks, God. Now I have to stop it all. Rory, you told me not to do it. Yes, you did. I decided to do it like last minute. Anyways, okay, we're gonna like assume that it works, right? Because we all trust each other over here. just to save you guys time. Anyways, so now I'm I need to make a change. So hello world. This is my AWS demo. Save. So now I'm a developer, and all I need to do is commit. So I'm going to stage my file, give it a nice thing, and say, hello world. Commit the file, push it.
Josh, what IDE or tool is that?
Get cracking. So what's going to happen on Team City is it's going to wait for the VCS change. It checks every 30 seconds. So what we decided, here you can see there's a pending change. You can see, yeah, it's initial commit. What we decided to do was for our dev environments to have an auto kick off the build, because dev, we want our dev branch to be updated really, really fast. Whatever's on dev branch must be just making sure that this thing, okay, cool, they picked up the other change a little bit. And hopefully it will run. If it doesn't run, I'll just do it manually. So dev branch should kick off automatically. UAT and live would be a one-click. You just click run, which I might have to do because the trigger is not working. Anyways, I'm going to kick it off manually, and it's going to run all those commands that it's meant to do. Repo. Okay, so it's putting my repo. You can watch the build log. Okay, so it's not working. Why not? Because I haven't made a deployment. is what I have to do. So let's go back. So basically what I did is I built the Docker image, I pushed it to the repo, I tried to update Kubernetes, but the Kubernetes says I don't have a deployment called AWS demo. So here's my AWS demo deployment, which I forgot, and this is going to be pushed at AWS demo latest. But what I can do, let's just do that.
That looks like a service, the deployment. The service definition.
Which one? This is deployment.
Is it different to a service?
Yeah, so your service file, they can be in the same file. This is what my service file looks like. It's exposing port 80 to port 80, and we've got type load balancer, meaning it's going to provision an AWS load balancer, pointing at this deployment. So we look for this app, AWS demo, by using the selector flag. So let's go do those things. Apply. I'll do my service first. Why? Okay.
For the services that you guys run as load balancers, does it provision a Elastic Load Balancer Pro service?
Yep, $20 a month per load balancer. So, yeah. Cool. So we should have a deployment up, and it's struggling right because I pointed it to AWS latest, and we have a service up that's provisioned an Elastic Load Balancer that's pointing there. So if we go there, it's not going to hit anything. Great. So let's try update our app again. Because so now try again. We're going to save that, and we're going to use our Kraken stage file. Try again. And commit and push. So now I can also demo to you guys how. Okay, so you can see my build's currently broken. So it should have posted a Slack message to me that to tell me my build's broken, which is quite cool. I'll just run it manually because okay. So because Docker caches every command, it's built really fast. We can see what it did here. Pushed and deployment, updated the image. If we go to our deployment here, you can see it's now green. And it's got that. Web services. You can see it now says hello. That's what it is. And that's all the developer had to do to deploy and will deploy a container. If we look at our registry, we can see our two Docker images. So we tag them by build number, so the developer can always go to the team city build and look at build number 6 and look exactly what was built, exactly what code was built then. Yeah, and that's cool. So now let's update it a bit. So we have our service here. Now I want to update it to this service. So this is what I spoke to before. Cool, so I added a couple of things now. I want to give it this domain name, awsmeetup.addit.io. I want to give it this cert. I want to block it to these IP addresses. And I'm going to map from port 443 because we're HTTPS to port 80 on my container. So let's do that. So I call that service 2. Great. So if I try to refresh this, it's not going to work. Why? Because I've mapped from 443 to 80. This is hitting on port 80. If I look at my service, I refresh that. You can see now it's got this label DNS route 53, and we can see that it's waiting on port 443. So if I hit it on 443 there, it's not going to work well because it wants the domain name. If I look at my route 53, what that route 53 deployment has done, hopefully, hasn't done, yes, it has done it. We can see here a new area code's been added, AWS meetup.valid.io, that's pointing to this load balancer. That's the load balancer that Kubernetes has done. So we copy that. And go HTTPS, equivalent 443. I'm hoping that it resolves. And now we've got our awesome Docker container hiding behind our Route 53 that's secure with our thing from certificate manager. Yeah, and the same process goes to updating this. The developer would just need to go commit the code, automatically build and provision around this. There's a lot of deployment strategies that you can do in Kubernetes, like rolling updates, A/B deployments, canary deployments, etc. But this is our standard Kubernetes rolling update, meaning it will provision the pod. As soon as that pod becomes live, delete that pod.
Yeah.
Thanks. Everyone, there's lots of pizza. Please take home because
Questions.
Oh yeah. Wait, hold on. I planned for this. No, okay. Any questions?
Is that not fair?
No, wait.
Answers a good question.
Yes.
How, if you're
I've got swag.
a relatively small application,
Yes.
and you're still fine on running 1 or 2 EC2 instances for your application, what's kind of the threshold to decide to move towards a Kubernetes type environment?
So you got to think about what you're going to be provisioning, right? So you're going to need 2 master nodes. You're going to need 5 etcd nodes, or you can use S3 for etcd. So you're looking at provisioning 7 more machines in order to run 2 nodes. Doesn't really make sense, right? So something like ECS plays very well there, as well as Docker. I think have their own ability to run Docker images, as well as Elastic Beanstalk on AWS. You can run a Docker image in Elastic Beanstalk just for like a single image. So depending, I don't know how many Docker images you're running, but if you go here, I was showing someone before. Yeah, you can run a Docker image there. So I think where it starts to go is like maybe 5, 6 machines is where you're going to want to start looking at a proper orchestration tool. So Elastic Beanstalk, select platform, and here you can choose Docker or multi-container Docker. So 1 or 2 Docker images or ECS. You can chat to John afterwards, he's ECS. Cool. Fidget spinner.
Yeah, I can
Yes.
I know you mentioned like that's looking into monitoring and trying to drill down into actual containers. I know from personal experience with ECS, you have one advantage is you have huge integration with CloudWatch.
Yes.
Is there any, have you investigated using CloudWatch as a...
So you can get CloudWatch on your EC2 machines,
Yeah.
and you can monitor all of that, but we haven't looked at CloudWatch into your actual Docker containers. Can you
should
do
be able
that?
to write custom metrics if you really want to do with CloudWatch.
Okay.
To drill into your CloudWatch, into your Docker container running on the instance.
Or some correct command to actually correct your logs.
Be very careful.
Yes. I don't have any more features on this side.
Can you, like, instead of going just for reserve nodes, so I just want to do a spot node?
Sure, yeah. And that's how we would probably do our dev instance, completely spot. Everything's exactly the same, except you can use it at any time. AWS have like recently launched, and I'll close the thing now, like new kind of spot abilities, so you can provision your spot node for like a certain amount of time, as well as there's like a lot of custom stuff around that. Terraform doesn't have that integration yet, but if you are going to do that, then do that. Like make a dev cluster up for just during the day and stuff like that. So anything can be spot, and you can get really big machines for really cheap.
Two questions in terms of cost, right? So, do you guys run one cluster with different namespaces for data UAT?
Yeah, we have one cluster.
For whatever?
Just one cluster for everything and separated on the namespace level.
So do you guys put notes and letters on the deployments to say that
For the-
cloud applications only allowed to run on the reserved instances?
Yes. That's exactly what it is. So there's a thing called label gun. I don't talk about it here, but you can just apply certain labels to your nodes. And like you can make your nodes live or whatever and just attract those parts to that node. And the newer version of Kubernetes 1.6 is bringing out a lot more functionality around selectors, meaning you can have like anti-affinity and taints and stuff like that. So try go here, but if you can't go here, then go here, and all that ability. So we see this like ability of deciding where your party is actually provisioned as being like being on the agenda of Kubernetes development.
And just the second one, in terms of the services, you said that you guys essentially provision a elastic load balancer for a service, right?
Not for every service. If the service needs to be exposed to the outside world, then yes. But obviously, if it's an internal service and it's just going to speak to each other, we'll just speak on the Kubernetes service level.
Why did you guys decide to go for that instead of having a single like a load balancer and running something like an Nginx ingress on as an ending set across your nodes?
So you can, Kubernetes also has like ingress ability. They have an ingress thing that you can do. For our case, all of our endpoints are completely different. So that we have different services that are running. It's not like /API and /something is a different thing. So that's why we're separating them on that level because it's a different application. Yeah, but we should do it like that. Like that's the way to do it, using Kubernetes ingress, which is exactly the same as the Nginx ingress. Anyone else? Cool. Guys, there's lots of pieces. Please take home. And thanks for listening. I hope you learned something.